Probability is a measure of the proportion of times that the event would occur if the experiment were repeated many times under the same conditions. An event is a set of outcomes that we are interested in. Random outcome is when the outcome cannot be predicted with certainty in an experiment. Random experiment is any experiment that can be repeated under the same conditions and where the outcomes cannot be predicted with certainty. If Alan from The Hangover can master probability, so can you. So this is a Venn diagram, and it's just going to help you understand probability better. The blue in the box we'll call sample space, which represents all the possible outcomes of a random experiment. It has a complement of an event within it, which refers to all of the possible outcomes within a sample space, except for the event of interest, which is the circle we have there. So that white circle is referred to as the event, so it has the set of outcomes that we are interested in. Suppose you flip a coin to see who's paying for lunch today. There are two possible outcomes, heads or tails. This is part of the sample space. Easy way to remember it is just picture the coin being flipped in slow motion in outer space, sample space. That's where the decision's pretty much being made, and you think it's going to end up as heads, so you call heads. That is referred to as the event. Tails would be the complement. Why is it called complement? If it goes against what you want, beats me. It should be called bad luck complement or something. So anyways, heads is the event, tails is a complement. So there are a lot of definitions that you need to know. I'm going to have you pause the screen and have all these memorized because they are useful and you are going to be tested on these on your exam. So as you can see in the formula, we refer to the sample space as S, the event as A, and the complement of the event as AC. Probabilities range from 0 to 1, where 0 means there is a 0% probability of the event happening, and 1 means there is a 100% probability of the event happening. Since probabilities range from 0 to 1, then probability A plus probability AC, which is complementary, must equal 1. If you think about it, this makes sense. If you have like a 50% chance of the coin landing on heads, and a 50% chance of the coin landing on tails, then you have a 100% chance of it either landing on, heads or tails. This is the formula for a simple probability. All you do is divide the number of ways a certain outcome can occur with the total possible outcomes. Suppose we have a 6-sided die and we want to know the probability of rolling a 2. So all you do for this is divide 1 by 6 and you get 0.166. Multiply that by 100 and 16.6% of the time you could expect a roll of 2. So I'll give you an example of a mutually exclusive probability problem. Imagine that you have a chance to win $100 if you roll a single die and get either a 1 or a 6. So event A is the probability that you will roll a 1, and event B is the probability that you will roll a 6. We also have the complement, which represents all other outcomes that are not A or B, which is the probability that you roll a 2, 3, 4, or 5. You hope that when you roll the die that it will either be a 1 or a 6 because, hey, you want to win the money. But you know that it is impossible for it to be both. This is so obvious that it seems silly to mention, but in understanding mutually exclusive events, it is important to note that only one of the two events can happen, not both. So you're going to do what you did with the last slide. You get 1 over 6 plus 1 over 6 because, we're looking for two probabilities here. And you divide the two, and you end up getting it equals to 0.33. So 33.2%. All we did here really is extend our previous formula slightly.